All right, let's start with a model. Again, the model, we're going to start with it. We're not going to use the models, but it just might help to see what this might look like or what this is here. So we have 2x equals 10. So I'm going to just do a little barrier here. I'm going to put 10 ones on this side. It's 8, 9, 10. And I'm going to put two groups because we know it's two groups of something. We just don't know what x is. Now, here are the two groups, okay? And we know that the same number is going to go in each group, okay? Same number is going to go in each group. So if we divide 10 into two groups, that would mean there's 5 per group, okay? All right. So two groups, x would be 5 in this case because x is the number in each group. So x equals 5. Both sides are the same. That's 10, that's 10. This is just asking us if you had two groups, how much would be in each group. All right. Well, let's show it with symbols. Let's show it with symbols here. Let's start with the equation 2x equals 10. Now, actually, I like doing multiplication ones the best. They're actually, to me, they're the simplest, the most straightforward. How do we get rid of times 2? Because we want to get the x by itself. To get rid of the times 2, we're going to divide both sides by 2. That's all we do. 2 divided by 2, that cancels out. And you're just left with x, which is what we want. 10 divided by 2 is 5. So that's what we got here, and that's what we got here. That's nice. That's nice. Let's just check it to make sure it's okay. We'll check. Do a little check. So we'll start with the equation 2x equals 10. That's like 2 times x. So do 2 times 5 equals 10. Well, 2 times 5 is 10. 10 equals 10. So that's a check. So again, we're doing the same thing. We're using the inverse. The inverse or the opposite of multiplication is division. We're going to show division like a fraction. And then we just check it to make sure that the solution we got was the right one. All right, let's try a couple here. 3x equals 15, or 3 times x equals 15. So we have 3x equals 15. I want the x by itself. Well, first I'm going to do my little barrier. I want the x by itself. Excuse me. I want the x by itself. We have a times 3 next to it. To undo the times 3, we're going to divide by 3, like a fraction. So notice, we don't see the division sign at all. We just see it's written like a fraction. 3 divided by 3, those cancel out. And you're left with x equals, what's 15 divided by 3? That would be 5. All right, so let's check it. We're going to start with the original equation, 3x equals 15. Next step, instead of x, we're going to put 5, but make sure you put like a dot between the 3 and the 5. 15. Well, what's 3 times 5? That's 15. And 15 equals 15. That's a check. All right, let's try again. This is going to look similar. I know there's decimals here, but it's the same idea. We have 8 and 4/10 equals 2 and 1/10 times x. Put a barrier here. Each side is the same. We have to do the same thing to both sides. We want to get the x by itself. So whatever's hanging around the x, we want to get rid of it. To undo times 2 and 1/10, we're going to divide both sides by 2 and 1/10. Divide both sides by 2 and 1/10. And what's nice is we do get the x by itself because these cancel out. 2 and 1/10 divided by 2 and 1/10. That goes. We're left with x equals. Now, 8 and 4/10 divided by 2 and 1/10. I'm going to check. I'm going to double check that. I'm thinking it's 4. So let me off to the side. I'm going to do 2 and 1/10 times 4. 1 times 4 is 4. 4 times 2 is 8. So it would be 4. 4 checks out. So there's our, actually, I'm going to circle that one. There's our solution for now. We're going to rewrite the equation. instead of x, we'll multiply by 4. I'm going to use the parentheses to show multiplying because it's decimals here, and I don't want to confuse the decimal for a dot, a multiplication dot. Now we already did this. 2 and 1/10 times 4 on this side is 8 and 4/10, which is the same thing as 8 and 4/10. And that's check. So 4 was right. 4 was right. All right, now this one we're going to leave until you come back because there's something about this one that's a little unusual. So I want to save that. I'm going to highlight this one to remind myself. So you don't have to do this one. I'm just highlighting it because there's something different about that one. Just reminding myself to come back to that. All right, the last one we're going to try today is a word problem. So just like with addition and subtraction, with multiplication word problems, there's a pattern. There's a pattern to it, okay? And the pattern is this. You have a part. Well, I don't want to say a part necessarily. I'll say a part. I'm going to say, just to keep it consistent, a part times a variable equals the total. Part times the variable equals total. This is also going to be like the groups, the number of groups times the variable, or how many are in each group. So the part is usually related to a group. How many are groups you have, or how many are in each group. I'm just going to put that in parentheses. The part is usually related to a group, some sort of group thing. But part times the variable equals the total. That's what it's going to look like. Got a number times the variable is the total. Okay. Vicente and some friends shared the cost of a package of blank CDs. Okay? The package cost $24 and each person contributed $6. How many people shared the cost? Well, that's what we're looking for. So we're going to let, let's see, C equal number of people that shared CD cost. So you might be thinking, like, why are people buying blank CDs? Well, about 20 years ago, or even more than that, people used to buy blank CDs and do what's called burn. They'll burn one CD onto another. So, like, if there was a CD that your friend had and you wanted to listen to, or you wanted to, like, have the music yourself, you could sort of copy the CD onto a blank CD. And that's what people used to do. So that's why Vicente and his friends were buying a package of blank CDs. Okay, now, to write this equation, there's a number. We're going to multiply a number times the variable, and that's going to give us the total. Well, I think the part is 6 because I'm pretty sure that $24, I think that's the total. That's how much the total cost of the CDs were. Each person paid $6. So that's kind of the number or amount per person. So that's going to be $6 per person times the number of people, which is what we don't know yet. Or actually, I'm not going to use V, I'm going to use C. That's the variable. Equals, well, the total was $24. So that's the multiplication equation. All right, so to solve this, we're going to we want to get that times 6 out of there. Want to get it out of there. So we're going to divide both sides by 6. We're going to do the inverse. Divide both sides by 6. The 6's cancel out, and we're left with C equals 24 divided by 6 is 4. 4. Okay. So then to check this, we're going to write the original equation. 6 times C equals 24. C is going to be 4. 6 times 4 is 24. And 6 times 4 is 24. That's just a basic math fact. All right, we're almost done with that. We just have to write the answer. So this means that C was the number of people that shared the CD cost. So we could say, for the answer for this one, 4 people shared the CD cost. I guess the more people that chip in, the less expensive it is per person. But that is. The only one you should have blank on this page would be the one that we left blank, this one here. And we're going to try the rest of these multiplication ones, including this one here, next time in class. All right, if you have any questions about this or anything else related to math, let me know. Hope you have a great day, and I hope to see you soon. All right, bye-bye.